Hello interwebs, welcome to Let's Fix Computers. I've got a Corsair Void headset here, and we're going to replace the battery in this headset. Now, I've actually done this exact video before, quite a number of years ago now. I can't remember how far it was. Knowing my luck, it was probably like 2 years ago. Anyway, I did this exact same repair on my own headset. This is a friend's. And it held up incredibly well. Every now and then I still get comments on that video of people going sort of, oh, is this still working and stuff like that. And it's like, yeah, I'm still using that same headset. And the battery I put in it is still going strong. You know, I think it's starting to wear out slightly. Again, I've got that same issue where if I'm having a lazy Sunday and I'm sitting with that headset on from, I don't know, 11 in the morning until 11 at night kind of thing. By the time it gets around to late evening, I'm starting to get the beep beep of a low battery. But, it's still doing pretty damn good. It's giving us solid 10 to 12 hours of, intermittent use, which is reasonably good. There are headsets that have a longer run time, but considering these things, I think these headsets always promised 10 to 12 hours. So the fact that it's still hitting that figure is pretty decent in my opinion. So this is a slightly newer revision of the headset than my one is. The key differences are they changed the microphone boom arm. My one had an older style one where they had indicator LEDs on the mic itself for mute and that kind of thing, which is it's okay. This one now has just a big red ring on it, which is a lot more visible. And they moved the charge indicator to down here as well. Slightly different design on the rocker as well, I believe. Hopefully this rocker is a bit better because the rocker on mine is really worn out. I'd like to try and replace it at some point, but I don't know if I can be bothered because the problem with repairing peripherals like this is there comes a time where, yes, they can be fixed, but once they get old enough and worn out enough that they need repair, you'll probably also have your foot halfway out the door and you're like, I kind of want a shiny new headset if I'm honest. So who knows? At any rate, though, replacing the battery in these, fairly straightforward. The hardest part is sourcing the parts, but we'll get to that. So the battery is in the, the battery is in the right-hand earpiece, and all the control stuff is in the left. So I'm going to leave the control stuff alone today because we don't actually need to go near that. We're just going to operate on the right-hand cam. So I'm just going to pull off the padding, just ease that off without tearing it. And we're going to take out all these screws here that give us access in. So I'm going to start unscrewing these. And I'll tell you now in advance as I unscrew them, you do need to be careful when you remove this cap because there are some very thin and delicate wires connecting the driver into the earpiece. And if you just suddenly go, "Ugh," with it, you'll rip those straight off. And again, on my old video, there were lots of people in the comments that were just like, oh, one of the wires fell off, what do? And you can solder them back on. Obviously, it's better if you don't have to, but you can solder them on. I'll show you when I get these screws out. So these are quite stiff. Let's fast forward. Right, so now that's loose. I'm just going to gently lift this off and flip it over. And as you can see, there's our very thin wires that are connecting it up. If they come off, they're going to come off from the driver here. And I'll give you a close-up of that. And because, as I mentioned, if these wires come off, you're going to need to get out a soldering iron. However, I wouldn't say you need a huge level of soldering skill to deal with these. So as you can see, they are soldered in. We've got a little bit of hot glue on the left one there, and this one is just bare as is. But these are fairly large solder pads, so it would not be difficult to resolder these wires at all. I would definitely say that a hobbyist with not a particularly special soldering iron could easily manage this. This is not something that is going to require a specialist iron, although obviously the better your soldering iron, the easier it will be. So yeah, if these come off, don't panic, that is fixable, but just try to take care in the first place. So now that's off, I'm just going to steer that out the way and put that down there. And this is the battery compartment here. So the first thing I'm going to do is disconnect the battery with this little jumper JST connector. And we've got another 3 screws to come out. So let's pull those guys out. What's holding you in? There we go. Once again, be careful not to snag these wires if you can, because if those ones come off of the little circuit board at the back there, again, they can be resoldered, but those guys are going to be significantly harder to solder. So keep that one in mind. So, now, spoilers, I've already had the cell out of this one in order to buy the replacement one, which I'll get to in a moment. So I'm just going to peel the cell out, and this one's going to come out very easily because I've already removed it once. But you need to pry it out from this cage here. And you can do that with, I mean, I've got a metal spudger here that you could probably screwdriver it out. But the important thing is not to pierce, tear, or bend the cell too much. A little bit of bendage won't hurt, but try to be gentle with it. Bonus points if you can discharge the headset first, so just run it down flat. Because if there's no energy in the battery, then that absolutely minimizes the chance of problems here. It's very difficult to get a battery into a dangerous situation. However, obviously, the more care you take, the less dangerous it is. So, you don't need to be super worried, and I'm quite happy just to get a spudger in there. Maybe if you can get some rubbing alcohol, let's just put that in there again a sec. If you were to just put some rubbing alcohol all in there or pour it down through those holes, you could severely weaken the adhesive in advance, which will make your life significantly easier. So we've got our cell out. Let's have a look at this cell and see what it is. So this cell, if I can find my calipers, so as with all LiPo cells, it will be a 3.7. And the rating on this one, it is a 1000 milliamp hour before I damage the label there. And it's a 55-34-50. So that means that it's 5.5 millimeters thick. There we go. It is 34 millimeters wide. Or 34 millimeters tall. Yeah, 34 millimeters wide-ish. That's a bit hot, but whatever. And 50 millimeters tall. If we get the board included in that. There we go, just about enough. They're always very approximate, these measurements. So that's what the breakdown of those numbers mean. And this particular one, it is a protected cell. It's got a little circuit board up the top there that has a charge protection circuit in it. And it has a 3-wire connector. So that is, the black is your negative, the red is your positive, and the white wire is a temperature sensor. Just so the temperature of the cell can be monitored from that protection one while charging. Now, these 3-cell ones are a bit of a pain to access. Just for posterity as well, the JST connector is... it is a 1 millimeter JST connector. So the distance between the pins is 1 millimeter. This is the information that I forgot to include in the previous video. So, I have jumped on eBay and I have sourced a replacement. Here is the replacement cell I got. Now, I ordered mine from eBay China, and I managed to get a 1500 milliamp hour cell. So we should get a much better runtime on this one. And this is an 80-34-50. So it is 8 millimeters thick ish. It is 34 wide ish, and it is 50 tall. There we go, 50. Now, that's not quite the same dimensions, but it's very similar, just a bit thicker. And I'm going to fit this in. Now, this guy won't fit back in the original cage very well. I might be able to cram it in there, actually. Can I give that some judicious bending? I just flatten the bottom of that a bit. Oh. Just about, but it's still too thick to go in there, really. And so what I'm actually going to do is I'm going to leave this battery... I'm going to leave this compartment out. Because this just takes up extra space, and we can actually fit in a larger cell without it. So as such, I'm just going to leave this guy out. And that's not really a problem. It's a battery holder. It might provide some level of protection. But to be honest, I don't think it's actually going to make any difference at all. You've got the driver between the batteries, the cell, and your ear anyway. So I'm not really fussed about that at all. I left this out when I did my headset, and it didn't cause any problems at all. And it does mean that you can fit a bigger cell in there that is a bit thicker, which is how we got up to the 1500 milliamp hour rating. Now, as for finding the cell, I was searching for 3-wire ones. And rather than... the sizes of the cells are very arbitrary. So trying to search for a 553450, I don't know if you're actually going to have any luck doing that. Certainly, I don't know if you're going to have any luck finding one in that size that is 1000 milliamp hours or higher. So instead, what I tend to do is I search by the capacity instead. I tried searching for 1000 milliamp hour, 1200 milliamp hour, 1500 milliamp hour, and then I just browsed through the eBay listings, looking at the different sizes until I saw one where I'm just like, yeah, that would fit in, and had the 3 connector plug on it. Now, the 3-pin plug is what makes it quite difficult to find. If we had a 2-wire plug, there would be a lot more choice. So if you're completely stuck and you cannot find the 3-wire one, speaking of which, is that even the right connector? Oh, big heck, I don't think it is. Oh, I've got the wrong one. I hate everything. I'm going to have to rewire that. Damn. Alright, I'm just going to check which size I ordered, because I think I ordered the 1mm one, which to me implies that when I'm measuring that as 1mm, I'm actually doing that wrong. 1 moment. Darn, yeah, I ordered a 1mm, and on closer inspection, that is actually 1mm center of the pin to center of the pin. Whereas the original one, if I actually back my calipers out a bit, so I'm actually at the center of those pins, is actually a little bit wider at 1.25, which is the next size up. So this is a 1.25mm plug. That's the one you need. So I'm going to have to do some rewiring of these cells, which is absolutely possible. I really didn't want to do that because I was just going to plug this in and be done. But whatever, I guess you guys get to see a bit more. Fine, okay. Well, let's continue. This is a good opportunity to do a demonstration of other things that we can do with this. So what I was going to say is if you're having difficulty finding the 3-wire one, you can cheat as well, and I'll show you why that is. Let's open up the old one a little bit and remove the cable. So if we probe the red and black plugs, there is our main cell voltage that's currently at 3.8. It's 3.7 nominal, so this probably means we're at a roughly 70 or 75% charge. Full charge is 4.2, but the normal operation for a LiPo cell is that from 4.2, it will come down heavily down to 3.7, and then it'll sustain 3.7 for as long as possible before it cliff drops down to 3.0, 3.1 minimum voltage. Which is why they say they're 3.7 volts nominal, because that's the target voltage. They do run hot when they're at full charge, but they will come down fairly quickly. So if we measure from, if we go to resistance mode and we measure from the black pin, so negative or ground, to the white pin, as you can see, we've got, right now, we've got about 12k of resistance there, 11.8 kilo ohms. And what we can do is I can show you that this is indeed a temperature sensor, because if I actually hit this with a little bit of heat, I'm just going to turn on my hot air station at just 100 degrees. And I'm just going to very gently warm that cell. And as you can see, that's now plummeting. So as we hit it with heat, that temperature plummets. So as we hit it with heat, that resistance plummets down. Whoops, I've jumped off of it there. And now it's cooling down again. That resistance is climbing back up. So that's how it measures. There's a thermistor in there where as it gets hotter, the resistance decreases. So if you could only get a 2-pin connector, you could stick a 10k resistor from the white pin down to ground, and that will just send just a fixed room temperature signal to the headset. So you could very easily put in a 2-pin battery and just trick it into thinking it's at room temperature all the time. So that's how you'd solve that issue. So 10k resistor from white down to ground. Now I'm going to remove this connector here and put it onto this one because I've got the wrong connector. So this will be fairly straightforward. I'm going to peel back the Captain tape here. And this is fairly safe to do. Just don't short the damn thing out. It's that simple, really. If you don't short it out, you've got nothing to worry about. Oh man, this thing's going to fight me. Let's grab... There we go. So now we've removed the Captain tape and exposed the protection circuit. As you can see, we've got two bare tabs that come off of the cell itself. And then we've got this little circuit board. And that is, these two chips are doing all of the work there. One of them is probably the main protection chip. And the other one is probably a double MOSFET package that handles incoming and outgoing current. The wires on the back, those are the bits we want. So I'm just going to grab my soldering iron and just reheat these and just remove this wire. And then I'm going to do the same process on my new cell and just swap the wires over so I get the connector I want. Actually, can I just remove those pins and put them in the other one? I'm going to test that because that would make my life a lot easier. No, the pins are a different size. That's not going to work. All right, abandon. Right, now I have just pulled out one pin just to see if I could just simply unpin the connector, unpin this one and just swap the plastics over. However, the actual metal pins inside the connector are also of a different size. So I do actually need to swap the whole shooting match over. That's okay, that's what I expected to do. So I shall turn on my soldering iron and we shall commence. And let's see, let's set... We're going in at 350. I'm going to keep the temperature down on this because this is a very small board. We don't need a lot of heat and we don't want to spread any heat around either. Now, you can solder onto these tabs, but you want to keep heat in the cell for as little time as possible. The less heat, the better. So I'm going to be very gentle here. Let's just go in and out nice and quick. One. I'm going to very carefully pull away the wires just so they're clear of the circuit board. Two. Oh. Adjust my angle. I'm trying to make sure I don't accidentally bridge anything. 3. There we go. That's that done. Now I'm going to peel back the Captain tape on the new cell. Nicely constructed cell this. Now, I say, those solder joins aren't very good, but that's fine, we're about to redo those anyway. Right, and our positive is high on this one. And I'm actually going to change down to a smaller tip. Okay, here we go. Much more controllable tip now. I might need to turn my temperature up a little bit just because, whoops, this small tip doesn't carry a huge amount of heat. There we go, that's 1 out. 2 out. And 3. There we go. I'd really like to replace that solder because it's all very frosty. But I really don't want to wick those pads. So I'm just going to go in and out and just get this done. All right, in comes the previous connector. That's one. For the record, we're using a small tip here, so if you're messing around changing wires on small cells like I'm doing here, you will need a specialist soldering iron. 2. And 3. Excellent. Right, now we've just got to put some fresh Captain tape on that just to keep it nice and covered and protected. So I will chop a piece off. Actually going to feed that through. You'll see why in a moment. There we go. Now I can fold that back on itself, which tucks it up against the cell. And that means that our wire is coming out in the right direction now. Oh, I'm drifting off shot. There we go. Right, and now we'll just put another bit of Captain tape around the whole thing. There we go. And everything is nice and covered and insulated now. I'm just going to chop off a little bit of the excess tape that ended up on that. This is just glorified electrical tape we're using. There we go. Now we have a new cell with the correct connector on it. I'm kind of annoyed that I got the wrong size because I ordered. If I'd known that I'd need to go through this shenanigans, I'd have just bought one in the UK and had it show up within a day or two instead of waiting like 3 weeks for this thing to arrive from China with the wrong connector on it. Doesn't matter. Now we have the 1.25 connector on it. This should now just drop straight into the headset. So let's do that. Bring you back in. That's going to go in like that. Just figuring out an angle for the wire. Although actually, that's sitting right there up against that screw point. That's not going anywhere. We'll put a little bit of tape in there just for good measure though. Right, I've just cut off just a little bit of Tessa tape, which is going to be just enough to hold this guy in place. Alright, and let's see if our driver fits down. Oh, that's all got turned around. There we go. Oh, that fits in a treat. Perfect. Okay, screws in. There we go. Now we'll put the ear cup back on. I need to see if I can track down some replacement pads or cups for these headphones as well, because they do wear out. And if you want to refresh a pair of headphones, putting some fresh foam on them is a really great way to do it, because you get that feels new feeling when you put the headset on. These ones are in pretty good nick. All of this is not frayed up or anything like that. We've got some fraying on the inside of the ear cups there. So that's obviously showing some wear and tear. It's not terrible, but it's enough that you're getting some bits that are coming out there. So it would be nice to replace that. But I haven't really gone looking for supplies. I'm sure they're out there for something like the Corsair Void headset, because this chassis, this design has been around for a long time now. I can't believe that no one has made replacement cups for these. Right, let's see if it works. Let's see, I'm going to plug it in. May as well plug it into this computer. Alright, the headset is activated because the RGB is on. Remember, I own a set of the. I own this headset as well, and yes, having RGB on your headset is stupid. I like RGB. You don't need it on your headphones. It's dumb and stupid. The annoying thing is you can turn the LEDs off in software, but it doesn't save that. You have to keep the software running in the background to switch it off. I'm very tempted to modify my. At some point, I'm tempted to open up my own set of Corsair Voids again, and I want to put an external battery on. I want to, I'm thinking of going mad lad and sticking like a 2,000 or 3,000 milliamp hour battery just on the outside of the headset, just literally gaffer tape to the side, and having like 24-hour runtime on it. And if I do that at the same time, because I'm just obliterating the headset at that point, at the same time I'm actually going to desolder the LEDs from the inside so these bits don't light up, because that's probably going to... Those LEDs, they're probably running at 20 milliamps, 50 milliamps each. And that's a lot of load on a wireless device like this with a 1 amp hour cell in it. So make of that what you will. Anyway, the headset is switched on. Let's do a test on it. But it's so hard to see what's across. So that's all I've got for you today. I hope you guys found that kind of interesting, and I will see you guys in the next video. Bye for now.